Okay, so now what we're going to do is just practice putting a polynomial in standard form. So you'll notice the three quadratics that I have here, f of x, g of x, and h of x, are all in general form. So we want to rewrite them into our standard form. And we know we can do that by completing the square with some modifications. So let's practice that, let's get used to it, and then we'll find another way to do it, which I know you guys are all going to like. Alright, so, but here's the hard method. So again, there's my steps. And so what I begin to do is I place parentheses around the part that I'm interested in. Right? So all the stuff with the variable is the part that I'm interested in. So there's step one. Step two, we're going to factor out the GCF. Again, sometimes it's a GCF. What we're really doing is factoring out the a. So my a is equal to -2. So I'm going to factor that -2 out. And when I do that, I get x squared minus 4x, right, minus 3. Alright, and again, you can always check yourself. If I redistribute that -2, I get what I had in return here. So I'm in perfect balance so far. Next step. Alright, so step 3, we're now going to go through our normal completing the square process. I've got what I need right here, right? That part in the parentheses is an incomplete square. So I'm going to take -4 and divide it by 2, right? That gives us -2. Again, hold on to that. And then -2 squared is 4. So there's the area of the missing chunk. So here's step 4, right? Rather than adding 4 to both sides of the equation, because that crazy looking f of x, what we're going to do is add the 4 to complete the square, but then to balance myself off, I'm going to immediately subtract 4, because 4 take away 4 is 0. Alright, and so this expression is equivalent to that. That's step 4. Step 5, we need to remove the subtraction part of the parentheses. So there's the subtraction I did to balance the addition of 4. I want to balance it out of the parentheses, but everybody's being multiplied by -2. So when that -4 comes out, -4 times -2, it actually turns into +8. Alright, and so there we go. And then, of course, now what we have, right, is now that we've done our work right, the trinomial that we have is a nice perfect square trinomial. And don't forget that -2 there's, that's what's always been used to factor. And then 8 minus 3 is 5. And there you have it. We've converted to our form. So we know we have a parabola that's opening down. As a matter of fact, we knew that from the very beginning. My vertex is sitting at +2, 5. And we can start doing our sketches. As a matter of fact, we can even answer a range question if we wanted to, right? So we're at +2, 5, opening downwards. So I know my range is from -infinity to 5. So much things we can do, all right, just by knowing that we have this nice standard form. Okay, but let's focus on, kind of getting ahead of myself there. Let's go ahead and focus on completing the square. All right, so the next two examples will be a little tougher, all right, but they'll hopefully kind of demonstrate what we're doing here. So again, let me try to keep my process over there off to the side as we do it. So again, the first thing we want to do, step 1, is put parentheses around the incomplete square part. So g of x equals, well, we have 1/4 x squared minus 3x minus 2. Again, the two terms with x in it are the terms that kind of determine that incomplete square part. Now what we want to do is factor out the GCF. All right, and so that's why I had the GCF in parentheses, because sometimes it truly is the GCF and sometimes it's not. All right, 1/4 and 3, there's not a nice GCF between the two. So what we're really doing is we're factoring out the a. So I'm going to factor out that a. And for those who understand that this is kind of like division, I'm dividing everybody by 1/4. So 1/4 divided by 1/4 is 1, so that's why 1's left there. And -3, if we divide, let me do the work there. If we divide -3 by 1/4, we multiply by reciprocal and we get -12. And of course, again, you can check to see if we're on the right track. If you redistribute this 1/4, excuse me, we get 1/4 x squared. And then 1/4 of 12 is 3. So I'm in balance. This piece here is still equal to that piece there. So mathematically I'm in balance. There's my incomplete square. So what do? Step 3 is we start following our normal completing the square process. Oops, let me align that. So we get 1/4 x squared minus 12x. What do I need to add and subtract? Well, we're going to take the negative 12 and divide it by 2, right? That gives us negative 6, and then we're going to square that, giving us 36. So we're going to add 36 to complete the square. We're going to subtract 36 to balance that action off. All right, so there's your modification. Next step, right, we want to remove the subtraction statement. So this negative 3x, I want to bounce out of the parentheses, but everybody's being multiplied to a quarter. So when I knock it out of the parentheses, what actually comes out, 1/4 of 36 is 9, and I'm negative, so we have a negative 9, and we still have the minus 2. So we're almost done. Next step is to basically, next step is to actually factor the perfect square trinomial that I've got. So we've got g of x equals 1/4. This piece right there will factor as x minus 6 squared. Again, that piece right there is always helpful. And minus 9 minus 2 gives us negative 11, and we're done. So again, thinking ahead, my a is 1/4. As a matter of fact, we knew that from the beginning. So we know we have a parabola opening up that's a little flat and compressed, and it looks like its vertex is sitting at 6, negative 11. So we can answer range questions, create a quick sketch, all that good stuff that we did back in 11.6. All right, so hopefully we're getting the hang of it. Let's do one more that even adds more complications and probably motivates. Please, there's an easier way. All right, so again, following my steps, I want to put parentheses around the incomplete square part first. Okay, next step is we want to factor out the a, or if we're lucky, the GCF, which this is not. So we're going to pull a 3 out of here. And remember, it's like division. So 3 divided by 3 gives us 1. If I take 2 and divide it by 3, I get 2/3. So there is basically what we have. And so now what we have to do is complete this square. So we take whatever b is, it's negative 2/3, and I divide it by 2. Of course, that means we multiply by reciprocal. The 2's will divide out, and we're left with is negative 1/3. So keep that in mind. I square negative 1/3, and I get 1/9. So what's going to complete the square here, I'm going to move that out of the way, what completes the square is adding 1/3. But to balance that off, I'm going to subtract 1/3 and that plus 1. So everything's happening inside of the parentheses at the moment. So we're basically at step 4 where we add and subtract our modification. The plus 3, these 3 terms are the perfect square trinomial. The minus 3 I like to bounce out of there. All right, but everything's being multiplied by 3 as well. Oops, excuse me. That should be a 9. 1/9, minus 1/9. That's what we're adding. Sorry about that. And so again, everything. So as soon as I bounce this out, it's going to be multiplied by 3. So we get 3 x squared minus 2/3 x plus 1/9. Close the parentheses. If I multiply 3 to 1/9, what I get out of that is 1/3, right? And then plus 1. So we're almost done. We're pushing some fractions around. So this factors, right? Again, that number right there always is the number we use to factor. And on the outside here, I've got some fractions to contend with. So common denominator is 3. So wrapping this up, what's h of x? It's 3 x minus 1/3 squared, and it looks like that's going to be a 2/3. And there's our general form. So we're a parabola opening upwards and pretty skinny, and our vertex is sitting at 1/3, 2/3. So it's going to be basically a low point. We can do our range and whatnot. So there's how we convert to standard form using the completing the square process. Obviously, sometimes it's nice and easy, right? The steps itself are pretty crazy, but you know, it's relative. This step right here is pretty crazy in terms of factoring out that a. All right. Sometimes it's the true GCF, sometimes it's not. All right, and so we got to be really careful with what gets left behind. I think another little tricky step before I shut it down is the idea that we're adding and subtracting the same thing to both sides. The addition to complete the square, the subtraction to balance this off, and then one last thing, when I bounce the negative out, right, the subtraction out, it gets multiplied by what's out there, right? So -2 times -4, we bounced out a +8. A 1/4 times a -3/6, we bounced out a -9, right? A 3 times a 1/9, what bounced out was a -1/3. So those are the little nuances, all right? So practice, make sure you got it. You will be using this in future math classes, all right? I'll talk to you guys later. We're going to build another way to do this.